What we have here is a simplified question. I meant to express this as one fraction. I don't know the lowest common denominator, so I can't currently think of what I don't know what the lowest common denominator is, but what I can do is just get a denominator. Okay? So what I do is I look at the denominator on the first batch here. I look at this denominator here, and then I look over the other side and see the other denominator blue. So what I do is I get the yellow one's looking at the blue one, and it goes, okay, I'll have the blue one on the top and the bottom. Everybody happy with that?
Yeah.
They cancel straight back out again, don't they? Leaving exactly the same number behind. So I haven't changed that number whatsoever. Okay, that's a bit awkward there. Now, next thing. The blue one looks at the yellow one, and what does it think? What's it looking at? 2x minus 5 and 2x minus 5. It goes, okay, now all of a sudden both of them are quite happy because both of them have the same common denominator now, don't they? They both have the same denominator, so all is good there. Okay, so that's pretty good. Okay, I'll just undo the mess I just made. Okay, now next thing, multiply out the top. What happens when you multiply out the top? Minus 9, yeah. And no need to multiply out the bottom, that can stay where it is. So x minus 3 and, or 2x minus 5 followed by x minus 3. Now, 3x plus 8x, and then minus 9 minus 20, and that's your answer. Okay, so once again, this fraction here, so which I'll colour in green. So this fraction in green is exactly the same as the original question. They're both worth exactly the same amount. Can anybody in the class suggest a method for checking my answer out of interest? Pick any value of x. This is a way to check that you're guaranteed to be right. So guys, what we're going to do is I'm going to pick any value for x I want. I'm going to pick, let's say, x equals 10. Is 10 okay?
Yeah.
Now, can anybody in the class tell me what happens when I pick out x equals 10? I decide to use x equals 10. What's this? 3 divided by 2 times 10? 20 take away 5?
15.
3 over 15. No bother. 4 over, what's 10 take away 3? 7. I'm going to say, okay, 3 over 15 plus 4 over 7 is what? You don't have to do this by just checking your answer. But everybody see 27 over 35? Okay, if this green part is exactly the same as this green part here, when I load 10 back in again, I should get exactly the same answer. Let's see if that's the case. Now once again, I'm going to be really lazy with this, okay? What's 11 times 10? And it's going to be minus 29 on the top. Are you happy enough with that? What's 10 take away 3? 7 on the bottom. What's 2 times 10? 20 take away 5? What should my answer be if it's exactly the same as the other green one? 27 over. That proves they're exactly the same number. Because when you insert 10 into both of them, the same number comes out twice. You don't have to do that, but in a test, if you had time, you could check your answer that way if you want. I'll do the next one, okay? This one looks really difficult. Why does this one look particularly difficult? Yes, sir.
There's adding at the bottom.
Not adding on the bottom, but there's 3 different denominators. Are you happy enough with that?
Yeah.
Now, can everybody see how far apart I'm drawing them? Do you think I'm doing this by, you think it's just me being sloppy? Not. I've done a lot of these. And you notice, see how big I'm putting the gaps at the start? See the way there's lots of space here? I'm going to show you why in a second. Right, green, blue, yellow. What does the green one see on its level? Sees the blue and the yellow, doesn't it? So it says, you know what? I want the yellow one and I want the blue one. What I do to the bottom, I must do top. 3 times x plus 1. To check if I've done everything right, what can I do? I could just cancel them back out again, couldn't I? And I'm still left with 1 over x. So it's still the same thing. Now I'm looking at the middle one, looking at the blue. What does the blue see left and right? It sees the 3 and it sees the x. And what do I have to do to the top then? 3 by x again. Finally, what does the yellow one see? Sees the green and the blue. Okay. Here's where things get difficult, okay? Is everybody happy that the denominator is exactly the same for all 3 of them? So we can just write down the denominator underneath. No bother. Everybody happy with the denominator?
Yeah.
Okay, perfect. Top part, 1 times 3? 3. 3 times x times 1?
3x.
Good job. 3 times x? Multiply by 2? Okay. 1 times x? X times x? Okay. X times 1x? Okay, slow down for a sec. We might encounter a problem here yet. Okay. The top is x squared. 3x plus 6x plus 1x. The bottom just plus 3, isn't it?
Yeah.
Okay, it's actually grand. Yeah, no bother here. And on the bottom, 3x plus x plus 1. Everybody cool? Can anybody in the class tell me how could I check my answer? Yes, sir.
Get a random number.
Pick a random number. Fair enough, Heyman. Pick me a random number, please.
8.
Heyman's picked 8. Do you got it? This means anywhere I see x, I have to replace it with 8. Let's find out. 1 divided by. Oh, sorry. So this only takes a second to check. 1 8. Yeah. What's the other one going to be? 2 over. If x is 8, what is it going to be? 2 over 9. Perfect. And then the third version is going to be. And what's the answer? 49 over. Okay. When you use x equals 8, the answer has to be 49 over 72. If I've done everything perfect, when I replace this with 8, it also has to be 49 over 72. Let's find out. So I press the fraction button at the start. So 8 squared, you happy with that? 10 times 8 plus 3. On the bottom, 3 times 8, x plus 1, which is 8 plus 1. You don't think you're right, you know you're right. Do you get the difference? How long did that take me? A minute? So that's the difference. If you know you're right, then there's nothing ever to worry about.